from my side, welcome everybody. And we're going to kick it off now because I know time is precious, and we're looking forward to sharing this information about Festo and Festo's artificial intelligence offering with you. So with that, I'd like to introduce my co-hosts today, Mr. Sky Prato, head of industry sectors and business units, and then Mr. Sebastian Verler, all the way from headquarters in Germany. Looking forward to what he's going to be bringing for us today. And of course, you hopefully all know me by now. My name's Marcus Gericke, and I'll be kicking it off for us today. So with that being said, guys, just a quick, how can I say, T's and C's. If you've got any questions, guys, during the presentation, please put it into the question section in the webinar platform. We have some guys in the background. Thank you, Haddis, for making yourself available to try and answer all of these questions. And we have some time at the end of the webinar for some questions that we think is either would be nice for everybody to get the answers, or maybe a little bit too technical for us. And we'll then, of course, liaise with Sebastian to get those answers. So with that being said, Sky, what do you believe we need AI in industry?
Well, Marcus, I think MIT sum it up nicely here, where they say digitalization in industrial facilities is critical to achieving new levels of safety, sustainability, and profitability. And AI is a key enabler for that transformation. Basically, I think in the future, companies that are competing will battle to compete and be competitive if they don't include AI in their facilities. Just as it seems like the next big at the moment, in the future, I think it'll become the norm. If you think about, let's take the automotive industry. Airbags were a new thing at one stage. Now there's hardly any cars that don't come out with an airbag. And so things evolve, and I believe AI will be the norm, and all companies, to be competitive, would need to get on board with it.
Awesome. All right, so with that being said, I think for myself, with AI, it's still quite a vast and new thing, like you said, Sky. So I want to just position where I see AI and where Festo fits into AI. So hopefully you'll see in front of you a pyramid, and this is how I've set it out for myself to grasp where does Festo actually fit in. So at the top end, you'll get your ERP section, where we can see AI already today taking care of, how can I say, customer trends, helping customers out there to do demand planning, to do production planning based on what the market trends are doing. Then the second section, the process optimization. This is where algorithms can be implemented in a step-by-step process, to optimize these processes. So imagine you've got an assembly line where you've got operators assembling parts. Let's say they're putting in a few screws, a seal, etc. You've got sensors, you've got timers, you've got all sorts of data available, and AI algorithms can now help to optimize those processes. Some of the guys that's in here, they actually implement those types of process optimizations using AI. So you can determine where bottlenecks are, whether it's day shift, night shift, whether it's between operator 1, operator 2, maybe a difficult section of assembly that can be automated. So AI really helps in that aspect. But then where Festo's offering really comes in is that bottom end, that machine and component level. And by implementing an AI algorithm, customers now get a preemptive warning for pending failures, whether it's an anomaly that appears, or maybe a cylinder or a motor is deemed to be starting to fail. It's going down in its life cycle, or its health score, which Sebastian will take us through a little bit later. This can now help you, and I think Sebastian will also touch it on a little bit later. How much do you actually lose in percentage of profitability on not being able to prevent these types of failures? So I'd like to just give us a quick rundown of how this AI actually works. So what we do is we take the data that's already available on the machine, whether it's on PLC level, whether it's on the sensor level. We take all of that data in and we apply it to what we call our AI algorithm. So whether you're taking live data or perhaps stored data, take all of this data, you can apply it to the algorithm, and we still have the human in the loop feature where we take the data, We then, of course, teach the model what we want to get out of the model, and we also do data validation. So let's say you get an anomaly, in the beginning, the human still needs to identify or classify this anomaly, whether it's standard. So if you imagine adjusting the airflow, your parameters have changed, so the human has to then accept it to say this is a different parameter. Let's say you're running a different product or a different SKU. So previously, there used to be so much data available that we didn't use. If it wasn't necessary for the process at the time, you wouldn't either display it or maybe use it in your process. Now, this is where we take that data, whether it's either supervised or unsupervised, and we classify the data to give us anomaly detection and, of course, look at what risks there are. But over and above that, how does that work? So we've broken it down into a few simple steps. So the first step is to take this data. So of course, in all operations, you've got sensors, you've got motors, you've got all sorts of data that's available there, whether it's a temperature, speed, pressure, flow. We take all of that data and we aggregate it, we put it together. Then the second step is what we call the pre-processing. So before we send these tons of data into an AI platform, we try and clean it up a little bit to get rid of things like white noise and a waste, of unnecessary data, because of course that'll cost again. So then the data transmission, this is where it's taken from, let's say, the PLC via field bus. Let's say you've got a Siemens PLC, then we'll take it via Profinet up into the AI algorithm, whether it's in the cloud or maybe an on-prem solution. We take that data, either OPCUA or perhaps MQTT, and we then take the data towards where we will then start to interrogate the data. So once the data reaches, of course, the AI software, it needs to be integrated and interrogated. So this is where, and Sebastian will show us, Nana, we take all of the data and we allocate it to a specific area, so that when there's an anomaly, it can tell you exactly it's on cylinder Y, sensor A, etc. So this is where we do that. The AI analysis then starts to process all of this data, and using various techniques, whether it's deep learning or machine learning, it starts to analyze this data by means of the algorithm, and it starts to identify patterns, making predictions based on the future according to this information, where we can then start to do tasks. And that, of course, is the sixth one, that action. So this is where the decision making comes in. Is this just a decision to trigger an action like maintenance, or for perhaps, to adjust process parameters? So again, if you've got AI algorithms applied, it can help you to adjust processes upstream to ensure that you have a good quality product come out at the end. So hopefully that's just, I don't want to say demystify, but just giving you a quick rundown, the layman's term of how this AI algorithm actually works. But Sky, the question to you is, where do you see the biggest benefit for customers to apply this?
Well, it's really at the factory level, at the machine process operation. And there's three factors that determine your overall performance and quality. The first is OEE, which is your overall equipment effectiveness. And here it's a measure of your effectiveness of your machine, broken down into three factors, which we'll dive into just now. The next is energy, and here it's expression of the efficiency. In other words, what resources does your machine consume? Steam, power, compressed air, etc. And the last is safety, and here it's about lost time instances. If we dive deeper into the OEE, overall equipment effectiveness is measured in percentage, and ideally we want to get as close to 100% as possible, which isn't necessarily achievable, but that's what we stretch for. If we look at the OEE, it's divided into three main factors: the availability, the performance, and the quality that your machine is producing. So it's the availability times the performance times the quality, and the result is in a percentage. Under availability, it's all about planned downtime, unplanned downtime. On the performance, it's about the idling and minor stops and reduced speed that can impact there. And on the quality, it's of course the reduced yield and your process defects. Keeping that in mind, how can we influence this? And it's pretty obvious that by knowing what, how, and where to apply our maintenance management, we can have an impact on our OEE. So if we talk about maintenance, what do we mean by that? Maintenance is all about striking a balance between cost and effectiveness. We all, in the past, I'm sure, if we're involved in a production environment, have applied a lot of effort sometimes into certain maintenance and got very little return with regards to effectiveness. So if we look at the maintenance itself, we can define it into 5 different types. The first being reactive, which is pretty straightforward. The part breaks, we stop the plant and we change the part. We then have preventative, where the part, we believe from experience, lasts, for example, 5 months. So at 4 months, when the plant is down, we change the part, anticipating that it's going to break soon, so we'll just put in a new part. We have condition-based. This is where we set certain alarms. And then we have the real focus today, and that's the AI on the predictive and the prescriptive. So if we were to have a look into that, you should be asking yourselves, what if the part unexpectedly fails? And that's how you decide which one of these maintenance types to apply. We don't want to apply AI unnecessarily and spend all of that money. So from experience also, which failure has the highest impact? And what do we mean by that? If we line up our impact arrow on the right-hand side with the 5 different types of maintenance, and we ask ourselves the question, what happens if the part breaks? What will be the impact? At the top of the arrow on the right-hand side, where it's green, if the impact is fairly low, then we just apply a simple reactive type maintenance. Stop the plant and change it. If the impact is high, this is where we would apply our predictive and our prescriptive type of maintenance, and that's where AI is based. So Sebastian, will you take us into a little bit further look into machine maintenance and the role of AI?
Sure, thanks, Guy. So if we look at that guy, a maintenance engineer generated by an AI algorithm, what's on his mind? So generally, the main task is, how can I optimize my maintenance process to ensure the best possible technical availability? As Guy was introducing already, availability is one of the factors of the OEE, and optimizing that really has a clear benefit on the well-being of the production and at the end of the outcome of the production. So at the end, studies and also experience that we have in our own factories, and which other studies have concluded, is alongside human error and material bottlenecks, component failures are one of the main causes of unplanned machine downtime. So for sure, there is human error, there's material bottlenecks, etc., but component failure is one of the key causes of unplanned machine downtime, and this attributes to 5 to 20% productivity loss. So that's quite a huge number to work on. Even if it's on the lower side, on the 5%, this is really something where we're working on, and introducing solutions really has a clear benefit. At the end, if we look at that graph, and this sums up what Sky was also managing with the certain levels of maintenance, we see on the y-axis the asset health, and the x-axis the time, and the curve just shows the asset health over time. We see at some point on the right side, an asset will fail, a component will fail. Whether it's 20 years or 1 year after, that's totally depending first on the component, on the environment, on is it a harsh environment, and so on. But at some point it will fail, and it's the goal of maintenance to prevent that, or to at the end fix it before it comes to unplanned downtime. At the end, preventive maintenance can make a good impact on that, but we are maybe too early, or we might be too late. So it's just about optimizing the cycle. Condition monitoring and having good thresholds already can help you prevent the failure. That's for sure possible, but the promise of this predictive and prescriptive maintenance, also with the AX industrial apps that we're introducing, is to have it really in it early in the degradation of the asset health, to react in a planned time window that maintenance has then to replace or to repair a certain part. Also not about repairing that part or replacing it, not to prevent the failure, but also in that time when the wear out starts until the failure, the performance of the component also decreases. And while this might not be a huge effect, and when we're looking at one part, it might sum up if you have many parts wearing out and cycle times really going down more and more because all the parts are not functioning that well anymore. So it's also about reacting to slowing down the process. So reacting early can help you in preventing that cycle times really goes down. This is especially, for example, if you're looking in body and white lines in automotive, if you have a huge number of power clamps, for example, and they are failing, this can really have an influence on your cycle time and then at the end, less outcome of your production line. We've done these solutions. Everything that we talk about in the next minutes, and we use these solutions in our own factory. Festo is a global company. We have global production facilities. One is in Germany, we have in Asia and so on, and then in South America and so on. So we are using these solutions and we are seeing the benefits of these solutions in our own factory. And this is one example where we applied our solution, monitoring a pneumatic cylinder inside of a drilling machine, of a shear run drilling machine, for the cylinder that moves and opens and closes the tool door. While we are not really monitoring the cylinder, at the end we are monitoring the cylinder, but it's more about the guiding that the cylinder actuates. And this, due to dust and metal, like the drilled metal, etc., this gets stuck from time to time. And by applying this algorithm and our software, it's possible to be really early in the maintenance process and notifying maintenance teams about something to be happening in the future. And if they react fast, we see that cost savings, and we've seen that throughout the last 2-3 years that we have installed the solution. We are saving up to 15,000 euro of still stand costs and maintenance costs by this one machine alone. Now you could argue that this is in Germany. We are high labor cost country. Still, if you reduce the labor cost of maintenance and maybe the downtime costs, because you're not maybe the downtime is not so expensive. If we say 1/10 of it, 1,500 euro, it will still be a great ROI in a few months of this solution alone on one machine. So it's always about how fast can I have an ROI on that solution and what does it bring to my production line. The benefits, and Sky already mentioned it, and Marcus as well, is we want to increase the machine safety. Well-running components are essential for machine safety. We want to have a less unplanned downtime. That's the overall goal. We want to increase the asset lifetime. We want to use the component until it's really in a bad shape. There's no need to replace it earlier, maybe. So we can increase the asset lifetime, also reduce inventory costs because we only need those parts that are really happening to be failing in the next few days, maybe. At the end, it's also about a shorter mean time to repair, knowing what part is wrong, where do I need to look at. This all helps me to reduce my mean time to repair, one of the key metrics for maintenance teams. Now, when we are looking at how do we use AI in manufacturing, and this is also what we did in the past and what were our expectations and what did we experience, we feel like, okay, we take any process in manufacturing, we apply some kind of AI magic on it. At the end, there's more magic to it, and there will be a value being generated for the production. The reality is we need to find suitable processes. Only then we will see benefits. Suitable processes are where we have a cost effectiveness, where we have data available, where we have a problem. You don't want to maybe spread it on all processes. We want to be really cost effective and have this applied on processes and where we can measure it also. We need solution engineering. Sometimes it's not so easy to get the data from machines, and maybe this is old machines, legacy machines, etc. We need to know which data do we need to maybe work on a certain problem. We need maybe some sensors, actuators attached to it, not always, but we need to work on the solution with engineering capabilities. Next, there's data science, where we think like, okay, now we have that data, what can we do with it and how can we make a change for that? And in the end, we will have a value, hopefully. We want to establish that value. We want to make it transparent for everyone. What does it bring? We want to take people with us, maintenance teams, all the other shop floor people into that solution. And that it needs to be change management, because sometimes the usual processes need to be changed to have these solutions implemented. You see, this is quite a big process that we are opening. There's a lot of disciplines in it, so it feels like this is really complicated. What you expect from solution providers, and we see ourselves now in the role of a solution provider, is scalable solutions that you can install in your machines easily, and the share of individual effort, the data science, the solution engineering, everything that I've told you, should be really low. Now, our solution for that is what we call Festo AI Industrial Intelligence, which is an industrial software solution stack to improve maintenance processes, increase the product quality, and lower energy consumption. By leveraging technologies like we've heard, AI, IoT, cloud and edge computing, all these things that are there, technologies, using them, making them fit to the industrial context, and at the end, generating a benefit and a value for you. Our industrial intelligence, we divide into two streams. We will talk about the left stream in the next few minutes then, but also let's have a few words about the AX solution part. This is the part where we take our solution stack and apply it to several industry processes. For example, in this example, this is automotive production, welding process and body and white lines, where we look at holistic solutions, monitoring welding guns spot quality, welding spot quality, conveyor belts, vacuum grippers for the metal sheet gripping, energy monitoring on these entire lines. So these are holistic solutions for specific processes. Sure, in these processes, while they are standardized more or less in body and white, but still they are quite individual. There's more individual effort to be done. And on the left side, we see where we really have achieved scalability and standardization, which is our AX industrial apps. We call them industrial apps, which are pre-built packages for you to take and install in your machines without having to go in this entire process. Now, let's look at a pneumatic actuator. That's what we are famous for, and that's what we bring a solution for. When we monitor that and we saw this process steps, like we find a suitable process, we want to monitor pneumatics because we feel like they are one source of downtime maybe on my machine. I want to monitor them and I want to be able to early react on possible failures of these components. Now, I see these whole steps, and what we've now achieved and what our solution is, we've taken this entire process and bundled it into this application, so you do not have to go all these steps by your own, but this application packages it for you and has it pre-built into this application, and you more or less have a simple solution that you can install that take away the individual effort for this specific use case, and you have the AI model that is capable of monitoring and predicting making anomaly detection on a pneumatic cylinder, where you have everything from the connectivity. You don't have to worry about We see that in a few steps, and we have a nice user interface where you can also work with the application. So now let's dive into that. Let's say we want to do that. You feel like, okay, this is a nice solution. I want to implement, I want to monitor pneumatics in my machine. This is the topology of the application that we've shown. Now there's a bit more technical. On the right side, you see the automation topology, where you have a PLC, you have valves, you might have a valve terminal, and you then at the end have cylinders that you want to monitor. We need, for this solution that we are presenting, we need limit switches on these sensors. You standardize, you have 2 limit switches, that's what we need on it. That's the sensors that we need, so there's no need to install any more sensors to it. This solution works with everything that is installed on the cylinder, 2 limit switches, that's what we need. We need you, and this is part of the connectivity stack, to install a Festo provided function block into your PLC system. We will show you how this looks like in a few seconds. And from that part on, everything is automated, and we are running the industrial app, for example, on an industry computer that is attached to the machine, or you have a centralized server infrastructure, or you want to run that in a cloud system. This is totally up to you, and to your IT strategy, what you want to achieve. I feel like OEMs and machine builders might want to have it on an industry computer running next to the machine, running this industrial app parallel to maybe some other applications that are running on that industry computer, and then monitoring these pneumatic cylinders. So where you run that, it's totally up to you. Basically, you need an industry computer, some kind of computing device to run our solution on. So at the end, you need a pneumatic cylinder, you need limit switches in our Motion Insights Pneumatic industrial app to be able to monitor pneumatic cylinders. Now, what we see here and diving in is part of the process steps that you need to do. You need to do some simple steps where we say this is something that you do or your control technician do every day, install a function block into a PLC. And this video shows you how this is going. We will not dive into the details of the function block right now. We have a great application note, a PDF document describing all of that in detail. It's just about showing you that this is now took us like 10 seconds in the video. It's a bit fast forward, but it's about 30 seconds or so, 30 seconds to 1 minute to configure that function block per cylinder, and then you're ready to go. This function block, there's not too much magic happening in it. It's basically doing some time stamping on cylinder movements and providing that data later for our application to collect it from the PLC system. We will provide these function block for all major PLC systems, starting with Siemens. Rockwell will come now, Beckhoff, and others will be provided via OPC-UA. Once we've got the function block installed in the PLC, now we are diving into the application, and we are now seeing that this is totally being done by a wizard guiding you through the connectivity steps. What we want to show you here is now this is not something that is really expert usage of a software. You basically need to provide some simple credentials, IP addresses, some configuration parameters that you get from your PLC and from your network topology. So you're guided, we are now jumping, we are guided by a wizard through this application. The video not playing. Let's go back again.
Get it to play this side?
Yeah, that would be nice. Thanks, Marcus. So we see we are going through a connection wizard. We are entering an IP address of the Siemens PLC in that example, some information that you get from TIA portal, entering the credentials to our application. This is all being described. And then at the end, you're ready to set it up. And then you're going into the application running, that is running on your computer. You need to run the machine. And from that point on, we need 300 cycles of the machine doing its normal job, of a case erector building up cases, of a palletizer, or whatever the machine is doing. You let the machine run, and we need 300 cycles, and you see the progress bar at the bottom. The algorithms learns these 303 cycles of normal data of the machine, and you're good to go. So basically everything is automatic. You start the application, we collect the data while it is running, 300 cycles are needed, and from that point on, the application then is ready to run, and we are now looking on a dashboard for one cylinder. Now we could have that for all the cylinders in one machine. And once this is, the machine goes into some abnormal behavior, maybe because of a flow of a leakage, of a big leakage, or something else is happening. Now we see the health score, the indicator for the well-being of the cylinder is going down, and this is where where it's time to react and to do maintenance on that certain part. You will be notified through this, and you can react now looking at that cylinder. Is it a cylinder? Is it maybe energy supply has been changed, something like that, and then really react specifically on that part that makes problems. So our industrial app, Motion Insights Pneumatic, is there to avoid unplanned downtime by continuously monitoring pneumatic cylinders in a machine for wear and other anomalies. This is a ready-to-use package, what we just described, including the connectivity via the PLC. You do not need to have any data science expertise or anything else. Basically, you need the expertise to install a function block in your PLC. The function block, we described it. We have all the parameters described. You need to install this function block in the PLC. Right now, there's no other way to provide the data. The PLC, going through the PLC, is in the pneumatic scenario for pneumatic cylinders. The only way at the moment to get the right data. But it's easy commissioning in minutes instead of days and having a long projects and doing this and that. As you can see in the picture, this works for Festo cylinders. It also works for pneumatic parts from other vendors. So whatever you have in your machine, Festo provides a solution to monitor pneumatics in your machine. If you ask yourself, that's great, how should I start? We say, pick the right cylinders to monitor, put it on the worst cases, and you will have a fast ROI on that solution. As Sky was mentioning, look at where's a high impact on product quality, on downtime costs, which are the cylinders that are not frequently replaced anyways, or that are difficult to access. Maybe they're somewhere deep inside the machine. This is where really there are the low-hanging fruits. If we look at that array of cylinders, these are 100 cylinders, we say about 5% are really the ones where you can look at. It's not about having now all the cylinders monitored. We are happy if you want to do that. But if you want to have fast return on invest on these solutions, take these ones, and we approximately have 5 to 10% of the cylinders are a perfect match for fast ROI to apply that on. It's not about going from 0 to 100% of monitored cylinders. It's about finding the right steps to optimize your machines, your production lines, and installing that solution. Where to look? Maintenance logs. If you're an end user, a production, a manufacturing company, you might have maintenance logs. This is a good place to start your search. If you're a machine builder, think about where is the crucial, the critical parts, the bottlenecks in your machine to apply this on and to provide this to your end user then at the end. If you want to run that, you can buy these licenses in the Festo app world. We think this is a great price point with 10,060 euro, not euro, your local currency for monitoring of 10 cylinders. That's the package to start in. For sure, you can ramp that up with more and more cylinders. It's a more or less, we say, a one-click installation in your preferred environment. You can run that wherever you want, on an industry computer, on a server, on a cloud system. And the commissioning of the connectivity and the automatic onboarding is done in the app, and it's pretty straightforward. From that point, we need 300 data sets of your machine running for fine-tuning data, and then the algorithm and the application is ready to run the solution and to work with that solution, and then you have this monitoring of a pneumatic cylinder. At the end, you might ask yourself, I can do that on my own, or I can buy that solution. It's at the end a make or buy solution. If you make that solution on your own, you can do that to your very own needs. Whatever you want to build, you can build it. But you have to build it, everything from the connectivity part, function block connectivity, to the application, to notifying systems, other systems having these capabilities. You can do that, or you buy that from a vendor of pneumatic cylinders with the expert knowledge, and you don't need to hire rare expert roles that build you these solutions. So it's about a make or buy decision, and we feel like, especially also with this attractive price point, it's a buy decision. We feel like this is the favorite decision in that application, to really buy that as a kind of accessory to your pneumatics, and to just install that and run that for you or your machines or your customers. As I said, you can run that directly on the line. You can have multiple installations on a line, all going together in one computer, in one industry computer, one server, etc. And we will, and you see that at the icons maybe, we will extend that solution also for electrical components, a solution which will come at the end of the year. The same applies, the same principle with the pneumatics then applies to electrical access, where we are monitoring electrical access that you have in your machines, where we have plug and play approach also with our own very own servo controller CMMT, and also to energy monitoring. Beginning of next year, we will have a solution for that. So you can combine that solution. Everything can run locally. So you have a holistic solution of your motion parts in your machines, easy and simple to set up, and then monitoring your entire machine for the motion part. If you have that, and if you think about what should I do with that, I don't want to look on a dashboard. That's not what maintenance teams are doing. They're not looking on dashboards. They are working on incidents. They are doing other things, but not looking at dashboard all the time. But you could also integrate that into other systems, IT systems. You could even integrate it into an HMI, for example. And whenever there's an anomaly, you see that on the right side in the dashboard, it's going down. And you see that then maybe as a kind of traffic light on the HMI, which notifies the operator, which then can notify the maintenance team, or you directly from our application have an interface to the maintenance management system and notify the maintenance team about something going wrong here and something to react on it. So there's benefits for our OEM customers and end user customers with our Festo AI industrial apps. End users, we've seen that they can transform into condition-based maintenance, predictive maintenance, and so on. They can take these solutions to follow their strategy, going away from reactive maintenance to more condition and predictive maintenance. It's about improving the overall equipment efficiency. But also machine builders can bundle that for their machines and sell the software package as an add-on for their machines, and or improve field service activities with it by being early notified about something going wrong, etc. So OEMs can build the solution into their applications. They can prepare their machines, being capable of running it, prepare everything, install the function block, sell the machine, and maybe also on a later time when the end user says, oh, I'd like to have some of these industrial app features, about these monitoring features, then sell a license to the end users, activating the AX industrial app while it's at the end customers, and then have a second business afterwards. If you're deciding to go with other platforms, I know Siemens has quite some interesting offerings, Industrial Edge, that's what they're calling. We will bring these solutions to other platforms as well. So you will find Festo applications on other vendors' platforms like the Siemens Industrial Edge, which is it's an industry computer plus some app store, etc. You will find our applications in these systems as well. So whatever you decide on, we want to help you on your preferred platform and then your preferred system. Maybe if you implement this solution, it's a great point, and now we are jumping a bit, thinking about a nice and easy way to do maintenance management. Say you have implemented the industrial app and you want a great tool to do the maintenance management itself, handling of the incidents, etc. And as a nice add-on feature, a quick way to diagnose faults on your Festo components, having access to manuals, etc. And this is our AX maintenance solution. This is another solution for maintenance management that also has the great ability that we show right here to access manuals and failure documentation of Festo components easily in a mobile app. This is an add-on to the industrial apps. So you can use that in parallel or only AX maintenance or only the AX industrial apps, but just to give you a hint about the nice feature that we have right here. Sky, why don't you want to sum up what we've just heard and give our listeners a few more details about it?
Okay, so then in summary then, when the page changes, 5 to 20% productivity loss. That's the potential that we're focusing on here when we talk about component failure that fails unexpectedly on the machine. That really is great potential that by focusing on that, we can improve the productivity of our machines. AI is not magic. Don't be afraid to integrate it into your concepts. We've seen from Sebastian here that Festo has specifically tried to create a concept that seems to be app-based. In other words, you apply the solution and you can repeat it again and again. It's not a customized solution. We do offer, as Sebastian mentioned, the one example in the welding environment, customized solutions. We do offer that, but these, what we're talking about today, is an app-based type of AI, starting with insights in pneumatics, and as Sebastian said, moving on to the electric side. The AX industrial apps encapsulate the efforts and make integration easy. As I mentioned, the idea is for it to operate like an app, and all the expertise is in there, and you apply and launch the app as such. Specifically, the insights pneumatics, as Sebastian said, plus minus 10,060 Rand. That's the license for a year for 10 cylinders. So it's very easy to try. I saw in the question someone asked, what happens if all the cylinders relate to a different part in the process? Each cylinder is managed separately in the app, so they can apply to different processes in your machine. So pretty much that's it from us today. Thank you very much for attending. I hope it was informative and it has inspired you to further implement AI into your processes. Thanks, Marcus and Sebastian. Just a reminder that recording link will be emailed to you if you'd like to refer to that later. And if you'd like any further information, please contact your local Festo representative or Marcus. There's his email there. He says he can't wait for your inquiry, all 600 of them. Thank you very much, Sebastian and Marcus, and to all the attendees. Thank you for joining us today, and we look forward to hearing from you in the future. A good day and enjoy the rest of the week. Cheers, everyone.
Thanks, everybody. Have a good day. Bye.
Thanks. Bye-bye.